Привет, меня зовут Андрей.
Hello, my name is Andrey Borodin. I'm developer Yandex and also I am PhD at Urals University and I'm developer of databases, and I also invest my effort into open source software and deal with developing a tool of replication storage Wal-g, and I'm going to speak about one small detail of this tool, that is incremental backups in Wal-g. Actually, in Yandex we're pretty scrupulous about redundant copies, and this presentation is one of many that I have given before and that were devoted to redundant copies. And let us recall what it is made up of. The easiest way to make a copy of your data is pgdump, an easy utility that allows to extract your data in logical form. That is a logical copy of your data that is usually independent of Postgres releases, and you can cut your database in snippets, and you can it is widely used in pgadmin, and it has a lot of settings, but we have to understand that first and foremost pgdump is a tool of service or application developer, not a tool to run database that would provide for fail-safe use of your database. And if everything is serious, you are most likely to use point-in-time recovery. That is a technology to recover your data for point in time, and it uses API to make backup copies, pgstart backup and pgstop backup. The first function, pgstart backup, makes some easy things. It does a checkpoint, and it says that changes in every page should get into write-ahead log. And it writes down when, at what position of LSN your backup starts. And you need to understand that a database copy made after pgstart backup call is not a consistent copy of a database. And files will change during your copying, and between start backup and stop backup you will need write-ahead log anyway, that will be needed to make your cluster consistent. The easiest way to come up with a redundant copy using API backups is utility in the box PG base backup, and it automates the call of the whole API and stores the log that you need for the time of backup. If everything is even more serious, the most popular solution to create copies is open source software Barman. That is a utility written in Python, and it enables you to create redundant copies from multiple servers simultaneously, one server of the database, and it is a really popular solution, and its main advantage is a large community and a large number of questions is its takeaway flow, and the documentation is pretty clear and it is supported by that community. But Barman has its disadvantages. On the other hand, it is pretty complex as it is capable of many things, and ideally it should live at a separate hardware, and the separate hardware is a separate monitoring object, and when you have too many servers, still you need to back up for several servers of Barman, and you need to track and trace their status and balance the load for these servers in such a way so that backups on one server would not exceed the limits of its physical capabilities, and therefore Barman starts posing a problem in itself as well. And the easiest way, the easiest utility to replace Barman is Wal-e. Here is a picture. that describes the main advantages of WAL-e easily. It is simple and it is not capable of anything excessive. It can do only what is devoted to. And it is devoted to sending into cloud storage or stream WAL files. And it has four main commands. WAL push, it sends a WAL into the cloud. WAL fetch receives the file from the cloud replica. Backup push sends it, and backup fetch takes the file back from the cloud. And WAL-e is capable of a lot of things as well, but it lives together with your database. It is not a separate monitoring object, and if you have hundreds of thousands of databases, it will not create you additional problems, apart from the fact that you need S3 compatible storage. And Google storage and Swift and file systems can be backed up to. And WAL-e can support a catalog of redundant copies in the necessary condition using one command of call. So you call WAL-e delete and it deletes all excessive things from your storage. And WAL-e has certain particular features. It is written in Python because it is convenient and handy, and it uses Unix conveyor actively, and that is why very often it is not very high performance. And the focus on the developers was on the use of, on the easiness of its usage when WAL-e was developed. As for the question where to develop WAL-e, there is no single or unanimous solution because there are very many features. Therefore, they decided to come up with another tool to avoid all Unix dependencies and Unix conveyor, and that is Wal-g. And in Wal-g, everything is encapsulated in one binary that is written in Go, and there is total refuse from Unix ideology, and several months ago, 6 months ago, almost, this was done, and this slide shows you the main difference of Wal-g from Wal-e. Here is a histogram of the base backup from S3 sent, and blue columns were Wal-e and red one was Wal-g. So median throughput is 2 or 3 times higher of Wal-g as compared to Wal-e, and there are practically no deviations from this median. Wal-g can also do backups from replicas, and you can avoid loading your master with write-ahead load, but at replica you can start creating a backup in one timeline, but while your backup is executed, somebody in master's string can promote themselves, and master will be cancelled. And it happens because it chose one of the timelines of possible future, and your data are not always possible to be used. And in case of changed timeline, Wal-g will inform the user that backup was created not fully consistent and give instructions on how backup can be recovered. But these backups are not recommended to be used, and they will be deleted in line with the recovery window that you set for delete command. And Wal-g can also do LSN-based delta copies, unlike Wal-e, and it means that when another backup is done, you can send to the cloud not all the data, but only the pages that have newer LSNs, newer positions in recovery log, and that critically saves the space in the cloud. And why do we need it? If we have WAL files, it enables us to faster recover cluster at a point of time. If you came up with a base backup at weekend, and you create delta copies every night, reproduction of WAL at high load base can take 5 physical seconds, and as for delta copies per 1 day, you will be able to roll it out several dozens of minutes. And for a long time, we discussed in our developers community what API should look like, and we decided that we have two key settings. The number of steps that can be done by delta copies by default, that is 0. That is when delta copies are not made at all, and every backup is full, and the target base backup that the current delta is calculated from. And for the base, it is logical to make to have delta from one and the same point. And if changes happen at different points, then it is logical to have delta from delta and another delta from another delta, and do so 6 times. While developing delta copies, we understood that it is critical to have a look at the correct format. The first format that we considered was just zeroing the pages that should not be stored, and Wal-g stores the database in archived way, but we opted for a format with better performance. That is when we store the number of block which is changed, and afterwards 8 kilobytes of data of this block. But in this format, we were not able to store format that would be compatible with Wal-e. So we needed to archive our data in tar, and we needed to know the size of our data file at the start of the write, and we needed to have all the list of the pages changed before we end writing the header of the tar file. Therefore, we opted for yet another format when all the changes from the start are stored, and the pages changed themselves are stored as well. In this format, the main problem is that we first need to find pages changed and then read them again if they have gone beyond the limits of page cache. But that does not happen often. Another feature that has not been done yet is optimization of rollout. If we have a base version where file was created and somewhere in Delta, in this case in Delta 3, the file was recreated, then from Delta 1 and Delta 2 status we could have avoided going through them, and this feature has not been developed yet. So if you have any ideas, I would be happy to welcome them, because it would speed up backup recovery, or I will do it myself maybe in summer, but first I will expect something from you. As for charts, here we have charts of the same database at the same day of the week, but we need to understand that they are different days anyway. And load during month changes as well. So in blue we can see load on disk, and this unevenness in Wal-e is connected with the fact that it can throttle the disk, but does it incorrectly. As for Wal-g load per disk, both a delta and base backup, it is always even, and it ends earlier respectively. And in Wal-e we can see critical peaks in loads on CPU. But most important thing that we can see from this picture is a spike of read from the disk on delta, and this spike says that we were forced to read the whole cluster to find the change in it. And of course it would be great not to have this spike, and we will discuss it further on. As for what else Wal-g can do, it can do prefetch when recovered. So your cluster is recovered from archives, and you request the next file 001, and Wal-g will also download 002, 003, and so on. And you can go to a different timeline, but that is a prefetch, so you will simply download several files, but anyhow, prefetch speeds up recovery of replica from archive.
Okay, now we have improved the deletion of Wal-g and Wal-e to the same level, same listings. So this slide shows the case of how we're working on Wal-g looks like. We have a number of settings there which the program uses. They're stored in the EPC Wal-g folder. So we'll launch the binary Wal-g and we do backup list command. We have a list of all the deltas and the base file which is stored. So in this case, the program will show all the available backups. It's just we have seven of them here, but it's just accidentally. So the most important feature of Wal-g. So to understand the feature, why it is important, you need to look at the previous episodes of this series of reports. So Yevgeny is here. He wrote incremental backups for Barman. And for the past 2 years, have been proposing them to the community and discussing them how to merge these increments with Barman. Also, 1 year ago, he offered this patch for Wal-e, and it was merged for a year. It is simply it was easier with Wal-g. I came to correct number of bugs. They made me to a committer, and have been developing this Wal-g for the past time. All the issues on GitHub are take like several half an hour probably to consider, maybe up to 1 day. But still, Wal-g is still getting momentum in the community. What else would we like to do with this? Our standard wishes, which we have been getting from the community, more cryptography, not just encryption, but also lipsodium and other backhand encryption tools. But it's not clear yet. We've been getting lots of requests for various storage platforms, Google, etc. But usually I say, okay, send me the patch, we'll have a look. Sometimes they tell me not just Postgres, other similar databases with similar APIs, but so far I haven't received any concrete proposals. So what I would like to do, at the moment Wal-g sends a WAL file to S3. Basically, you could pre-process them, and you could use these WAL files to get changes that we will need to send to the cloud during the next backup. I filled in the proposal for the Google summary of code. If your students, please prepare proposals to the list of PG hackers. We will discuss it. Maybe you will help me to do this in the summertime. You will help me to improve Wal-g. Well, and basically, if we use this information from the files that have been sold, that will help us to cut off that particular spike, which I showed you previously on the graph. Another patch which has not been committed yet, it is not clear when it will be. It was prepared by Postgres Professional. It helps you to get changes at the page level. The list of changed pagers in the form of a bit card. The p-track deltas differ slightly. So this graph shows you schematically the changes which we remember record in delta based on LSN. We get all the changes starting from one backup to the beginning, from the beginning one backup to the middle of the next backup. In case of the PTAC, all these delta must meet in the middle. They should meet only each other. So after we receive the changes from data, we basically clear the card that has been tracking the changes, which makes it impossible to show latest full as the aim for calculation of the backup. You always make a backup starting from the previous state, from previous flushing of the code. So what I was proposing, I proposed it in last August, that we make a patch that makes API inside the core, so that we could use a Postgres extension that would monitor these files changed. But unfortunately, after we discussed this patch at the community, we could not come to a single denominator. So we thought that we needed first prototypes and tools. But at the time, it wasn't clear to me why we need this. So this coming summer, I'll try to make a prototype of this technology. I will try to make another patch for monitoring changes in the core. But basically, there's this proverb that each Postgres has to make his own backup tool. Basically, this is a problem, because there should be one out-of-the-box backup tool. So we need to focus on developing base backup. But for the base backup to reach the functionality which we have in third-party tools, you need to submit your data to the cloud. You need to it needs to do all other backups. But Postgres is almost at the level PG rewind. But it's only the tip of the iceberg. We also need compression, which is not there. We need concurrency, we need encryption, we need throttling, listing, verification, operations with deltas. And these all activities are not available in base backup. So it would be the right thing to focus on what is in the box. And there's not so much in the box. Actually, there are very few activities, as if we compare them against third-party tools. Well, this is basically all I wanted to say in words. Questions?
And we use WAL-e and Wal-g a lot in our database environments and on our managed servers. One question is that we are trying to figure out how to solve the follower hole problem. So basically, when you switch timelines, when you're doing the replication from wall logs, how to jump from one timeline to another, especially if you do upgrades or maybe not upgrades, but failovers. So one thing is that we believe that with Daniel, solving it in the Wal-g level would be pretty optimal, because it can supply the required WAL files from one timeline to another. So what do you think about it? Would it be possible to solve it in the Wal-g level?
I didn't quite understand what's exactly a problem. Do you mean applying WAL files from one timeline to cluster within another timeline? It's absolutely impossible.
So basically, if your server is failed off, basically that means that you need to promote a standby to a primary, right?
You promoted a master of current cluster, which is backuped.
Yes.
Well, Wal-g will do absolutely consistent backup in this case, but it will not upload JSON Sentinel file of the end of backup. And you have to manually understand which timeline was followed. because now you have some changes from that timeline which were written by your replica. So you have consistent backup, but you don't have consistent Sentinel file. Because Sentinel file contained old timeline ID. And your backup is no more on old timeline. You have to create new Sentinel, but that's it. Actually, this is empty JSON file. You have to figure out correct name for it. And your backup from replica server will be absolutely okay. It will be restorable and it will be fine. Just don't make mistakes when pick correct timeline when you are creating this JSON Sentinel file. So this functionality works. I've tested it.
Is it built in Wal-g currently? Do you know that?
Yes, I've been developing this feature and it's built in Wal-g. Wal-g detects when it is working on replica and after finalizing backup and uploading PGConf file to cloud, it checks what is timeline now. It compares timeline from the start and the current timeline, and if they are different, Wal-g instructs user, prints into standard output instructions on how to use this backup. And I've added some functionality so that these backups from changed timeline would be deleted correctly during Wal-g delete. Thank you for your question.
Andrey, I have this question. You were mentioning a comparison with ptrack. We did not use we're not talking about comparison. There's an experimental version of Wal-g which uses ptrack, and as soon as it is committed, maybe we will be supporting it too. Well, I was thinking of using a different mechanism. That you have to be related to a full backup, otherwise you will not be able to restore. That's right. At the moment we're using different mechanism, but the ptrack mechanism is better. But we cannot use it because it hasn't been committed to the master yet. So you need to, we are waiting for it to be committed. That's right. We will be testing it before it is committed. We are already testing it. I participate in the discussions. I want ptrack to be committed, either ptrack or any other analog IP, which helps to do incremental backups at the core level. They must be committed because it's a good functionality what many competitors have, and we want to have it too. So you are for binary cards. You support binary cards, all right? You know, I don't think this is the best choice, but at the moment we have no choice at all. As regards the format that is going to be the best, I'm not ready to give you a clear opinion, to tell you that is the only right way at the core level. So currently you're comparing, testing, etc., right? Thank you. More questions? Thank you for this report. I'm welcome, Nikolai. A short time ago, I found your project. I'm probably a beta tester. I need to migrate 4.5 terabytes from one server to another. I tried simple replication, and I found that I was too lazy. It took me 2 hours to transport 20 terabytes. I have 11 pairs of master and slave, and the replica was based on base backup. It took me 1 hour to store it, then I restored it and launched the restoration on the other. I'm quite happy, and it takes a lot of quite a long time to catch up. The slave took a long time to catch up. What I did not like, that they wanted to confine me to full page write, because it is switched off by default on. So when I clone my Wal-g, I tell the system push, but it says I cannot because your full page write is not on. So why cannot I select whether I need put on this full page point or I don't? Clearly there are some mechanism of which I didn't name, some features. That's right. It's a very special feature of the API. This here, what we do. So, this PG start backup checks several preconditions, and it switches on the full page write. Well, in theory, it should switch it on if you're working on the master, or if you're working on the replica, it must demand that you do so. Unfortunately, this is beyond my control. I cannot overcome this. The thing is that we cannot guarantee the atomicity of reading one page when you read off from base backup from disk. So if we upload the first 4 kilobytes with the page header, which has the LSN from one version, and we take the other 4 kilobytes from another version, we will get the so-called torrent pages, which cannot be restored without full page write. So full page write is a way that Postgres uses to find the non-atomicity of reading. In theory, if you use a tool that would guarantee the atomicity of reading, you could switch that off. But in case of API for backups, PG start backup, this is basically impossible at the core level. There's nothing I can do about it, and this is good so. But could you please write it down in your documentation at least? Yes, I think this should be mentioned, definitely. Question: can we use your tool for production, because I need to migrate? 5 terabytes are there, I cannot do anything about them. Because the results I saw, I liked. Because it took me just one day to go back and forth with all the hustle and fussle. So I need to basically create a number of layers. So I need to command the system to take the data, etc. Okay, look, about using this in the production version. Well, clearly you need to look at whether you're ready, whether you understand all the risks which this tool implies. Wal-e has been tested better than Wal-g on one hand. On the other hand, I'm quite ready to support. If you find bugs in Wal-g, I'm ready to check them, to correct them. Basically, at Yandex, we've been looking for these bugs too. Basically, nobody guarantees that there'll be no bugs in Barman or Postgres for that matter. Bugs do happen, unfortunately. You should be ready for them. So, I couldn't give you a number and tell you, here's my number, call me any time of the night. But all I can tell you that if you find a bug, write to me, I will answer to you. Anybody has any questions? All right. I think there's a bug at the microphone too. Good afternoon. I'm Alexander Kukushkin from Orlando. I tried Wal-g. You showed very well that it is that it supports this prefetch. But there's a problem. Wal-g cannot do look-ahead for the files that are ready for archiving. Wal-e can manage this. So it runs to the archive status, sees that some files, some archive logs are ready to be archived for archiving, and it archives them, and there it goes. Maybe, and then it renames them ready to done, which clearly accelerates the archiving a lot. Well, archiving a lot. Can you clarify this a lot? Yes, I cannot give you the numbers, but WAL-e in Python works much quicker and by order of magnitude. So, when we use Wal-g, we saw that we accumulated several hundred of gigabytes of archive logs in a matter of hours. Yes, that is true. We had reports about the archive status, but also had received reports in terms of KA. That is, people were telling that WAL-e uploads files like this, and Wal-g does files like that. I have not been considering this issue from the point of view of performance.
If you are saying, well, performance suffers really, because if you send 32 files once, that is worse than launching archive command 32 times. Okay, I will consider this. If you help me, it would be great. I am not asking for requests. Naturally, I will write the code myself, but discussion would be really very handy. If you send me an email, I believe that I will find time and we will find a patch to that. Any more questions? Grigory Smolkin. Do I understand it correctly that the main penalty of your method is double read? So first we need to read what we have in backup and what we have in PGData, but in your case that is 3 reads because we need to read PGData twice. As first you have these offsets, you write these offsets, and then you reread PGData for the 3rd time, believing that these pages are still in the file cache. Do I understand it correctly? Well, ideologically speaking, yes, but how come that we have 3? Because we need to compare a span of the previous backup? No. We know the start of the previous one, and everything that changed since the start of the previous will be backed up. And if not so, we would have had just 1 read. But that is not a problem. The number of reads is not a problem. We have never gone beyond page cache. The problem is in the read, not in the number of reads. The problem is that we need to read this cluster that takes several terabytes, and it is worth money and kilowatts per hour. And would like to avoid that. We can see that this load is shown in this chart, and it means a lot. This spike, the bottom, that is several hours. Okay, then another question. Have you thought of coming up with a map of blocks changed while WAL segments are sent to the storage? Here it is. Okay, got it. And I would like some student to do it. I wanted to write it myself first, but then there was a question who would like to be mentored Google Summer Code, and I thought it is such a great task, and I'm so willing to do it myself, so let the student do it. Actually, there are so many pitfalls here, and we have implemented it on our side, and we have encountered. Does your license allow our student to look to your code? The license does not go. Some ideological moments can be stolen, and we will steal prefetch from you because this idea is really cool. I would call it collaboration. Thank you. Andrey, let us have a look at the slide with contact details. Any more questions? No? No more questions? So I believe that we have no more questions. Thank you very much for your presentation, and we have 18 minutes left for the next presentation. So I believe that we can have a coffee break, have a rest, and at 6 we will be looking forward to seeing you for the next presentation. Thank you all very much.